Hi, I'm Professor Piggy, and today we will talk about moms. Mothers. Motherboards.
Okay, jokes aside, let's get right into it. We spend so much time talking about the flashy processor or that huge, powerful graphics card. But today, we're talking about the single most important component inside your computer. It is the foundation, the bedrock. Really, it's the one thing that everything else depends on. Because without it, you just have a very expensive box of parts that can't talk to each other.
So, let's start with the big picture. We're calling this section the computer's central hub, and that's exactly what it is. Think of it as the fundamental infrastructure for your PC. It's not always the most exciting part to look at, sure, but trust me, without it, nothing, and I mean nothing, works.
So what is a motherboard, really? The best way to think about it is as the spine of the computer. It's a perfect analogy. At its core, it's a printed circuit board, or PCB, which is just a fancy way of saying it's a slab with a complex maze of copper pathways, or traces, etched right into it. This maze is the computer's central nervous system. Without this board physically connecting everything, your super fast CPU and your massive hard drive would just be, well, lonely, silent components.
Let's expand on that idea. If the motherboard is the spine, you can also visualize it as the entire grid of a bustling city. All the components, the CPU, the memory, the graphics card, they're like the major buildings. The downtown offices, the library, the power station. And all those little copper lines on the board, those are the roads, the highways, and even the subways, carrying information at incredible speeds between every single part of the city.
But of course, just like cities, motherboards aren't all the same size. They come in different form factors. The most common one you'll see is ATX. That's the standard size for most desktop PCs, and it gives you plenty of room for expansion slots to add new things. But on the other end of the spectrum, you have something like Mini-ITX. It's way smaller, designed for those really compact computers where every inch of space counts. The trade-off, you get far fewer slots to plug things into. Alright, so every city has its most important buildings, right? The VIPs. Well, on the motherboard city grid, the two absolute VIPs are the CPU, the computer's brain, and the RAM, which acts as its short-term memory.
So, this leads to a pretty important question. Where exactly does this brain, the most critical chip in the entire system, actually live? It doesn't just get plopped down anywhere, it has a very special, custom-built home.
And here it is, the CPU socket. You could call it the throne for the computer's brain. It's this incredibly precise mechanism designed to do two things: hold that processor securely in place and provide the thousands of tiny electrical connections it needs to communicate with and command the entire system.
Now, how that CPU actually connects to its throne is a really clever bit of engineering. There are two main ways. You've got PGA, or pin grid array, where all the delicate little pins are on the bottom of the processor itself. Then you have LGA, or land grid array, where the pins are actually in the motherboard socket. Now, why does this matter? Well, think about it. If you bend a pin, and believe me, it happens, with an LGA socket, you might have to replace a motherboard. That's bad. But with a PGA processor, you might have to replace the CPU itself, which could be way, way more expensive. It's a design choice that really shifts the risk.
Okay, so the CPU does the thinking, but it can't hold much information itself. That's where the memory hierarchy comes in, and the motherboard connects it all. Right on the CPU, you have cache. Think of it as a tiny, super-fast notepad for what it's working on right now. Next, you have the RAM slots, which hold your memory modules. This is the workbench where you lay out all your open programs and active files. And finally, connected to the motherboard, you have your storage drives, the giant filing cabinet where everything is stored long-term. The motherboard is the manager, making sure data flows seamlessly between all three.
So we've got the brain and its workspace set up, but what if you want to add new features? Or how do you access that huge filing cabinet of storage? Well, for that, you need the motherboard's data highways.
The most important data highway on any modern motherboard is called PCIe, or PCI Express. These are those long slots you see. They work using lanes, just like a real highway. A small little X1 slot is like a single-lane country road, perfect for something simple like a Wi-Fi card. But that big X16 slot? That's a 16-lane superhighway designed to handle the massive amounts of data a powerful graphics card needs to pump through it. It's all about matching the bandwidth to the device.
The way we connect those storage filing cabinets has also changed so much over the years. We started with these massive, wide PATA ribbon cables in the 90s. They were slow and just awful for airflow inside the case. Then came SATA,
with its much smaller, faster cable that's been the standard for a long time. But now, the coolest thing is the M2 slot. It lets you plug a storage drive, which looks like a stick of gum, directly into the motherboard. No cables at all, which means unbelievably fast speeds.
Okay, we've talked about the big stars of the show, the CPU, the memory, the graphics card. But none of them could do their job without the essential support crew. These are the unsung heroes of the motherboard, the components that work in the background to make sure everything runs smoothly.
First up is the main power connector. See that big block of pins? Think of that as the main power substation for our entire motherboard city. The power supply from your computer plugs right in here, and then the motherboard's incredibly complex circuitry takes that raw power and distributes it safely and precisely to every single component that needs it.
Next, there's this little chip right here. It holds the BIOS, or on newer systems, the UFI. This is basically the computer's fundamental startup manual. The very first thing that happens when you press the power button is this chip wakes up. It runs a quick check to make sure all your hardware is connected and working, and then it tells the computer where to find your operating system to get things started.
And have you ever wondered how your computer keeps the correct time even when it's been turned off and unplugged for a week? That's all thanks to this little guy, the CMOS battery. It's a tiny, coin-sized battery that provides a constant trickle of power to a special chip that remembers all those basic BIOS settings, like the date, time, and which drive to boot from. Without it, you'd have to reset your clock every single time you powered on your machine.
And that really brings us full circle, doesn't it? From the most powerful processor down to this tiny little battery, every single component, big and small, relies on the motherboard. It gives them a physical home, it gives them power, and most importantly, it gives them the pathways they need to communicate. It is the ultimate unifier.
So, after all of this, let's go back to that original question. What's really the most important part of a computer? Is it the CPU, the brain that's doing trillions of calculations every second? Is it that amazing graphics card that's rendering entire worlds in real time?
Now, it's neither of them. The most important part is the one that lets all the others work together. It's the motherboard, the silent, essential foundation that makes everything else you love about your computer possible.